there was a selected first presenter because you have been put up here, Yongqiang. But our first paper on the list here we go, is Natural Attack for Pre-trained Models of Code, being presented by Joe Yang. Please take it away.
Hi, everyone. This paper is titled Natural Attack for Pre-trained Models of Code. I'm Joe Yang, a PhD student from Singapore Management University. There are many research work being done to use AI models for solving software engineering tasks, but these models of code are not robust enough. One example illustrated by the left figure is a model can correctly classify the input, but if we change a variable to something else, it will be wrongly recognized by the same model, even though the program behavior is exactly the same. The fact that semantic preserving transformations on code can change the model outputs highlights some security threats. Assuming there is a malicious programming in a company, and the company deploys some AI models to conduct several software engineering tasks, like detecting the defective code, the attacker wants to cause some negative impacts on the code base. For example, merging buggy code, just negative impacts. To avoid being detected by the model, the attacker uses some semantic preserving transformations without modifying the function of his code to create adversarial examples. The model of the code are usually deployed in the server where the attacker cannot access the white box information like the model parameters. So this paper assumes a black box attack setting. However, software development is still a human-in-the-loop activity. Code review is widely adopted as one of the best practices. If we look at the adversarial example on the left side, changing LM to some other variable names like music services is actually not natural. They are very likely to be treated as bad identifier names, and as such obviously unnatural adversarial examples might be able to fool the model, but can be rejected by the human. So we suggest that the adversarial examples for model of the code should consider two requirements. On the one side, it should be program semantic preserving. It cannot change the program behavior. On the other side, it should also be natural to human judges. We quote one statement from a project in UC Davis. It says that software, as written, has two audiences, the machines that run it and the humans who maintain it. This, to some extent, inspired our study. We also find some very good papers sharing the similar opinion in EXIT 2022. We use a mask language prediction function from the pre-trained models code to generate natural substitutes. We feed the left text, I have a thing, which is hard to solve, okay, into the codebird, which can predict the mask token as a problem with a very high probability, followed by a bug and another problem with the first character being capitalized. The results are natural, as problems and bugs can be hard to solve. It means that the mask language prediction function can predict words that can fit into the context. So the above example motivates us to use mask language prediction function to generate natural substitutes for identifiers in the code snippets. For example, an original identifier is the prop, and the codebird can predict the natural replacement property, which can describe the type of this variable. We can extract all the local variables from a code snippet and generate a list of the candidates for each variable using the mask language prediction. Beyond that, we re-rank the candidate list. We use each candidate to replace the original identifier and then feed them into the models again. But this time, we compute the embedding of each token rather than predict the masked tokens. Then we compute the similarity between the original and the new identifier and select the top 30 candidates with the highest similarity. We propose a two-stage method to generate adversarial examples. The first step is a greedy algorithm to find these examples fast, and the second one is based on a genetic algorithm, which is applied to do a more comprehensive search if the former one fails. Due to the time limits, we refer the interested audience to the full presentation or the paper for more details. We choose two state-of-the-art pre-trained models as our victim model and evaluate it on three important tasks, including vulnerability prediction, clone detection, and authorship attribution. We conduct a user study to analyze the naturalness of adversarial examples generated by our method and another two methods, MHM and MHMNS. Okay, so the participants were asked to give scores on a 5-point Likert scale, deciding whether they think the new variable looks natural or not. 1 means strongly disagree, and 5 means strongly agree. We plotted the average score in the figure, and the results show that the participants consistently think that adversarial examples generated by our methods are more natural than the baselines. We use 3 metrics to measure the performance of an adversarial example generation methods: attack success rate, variable change rate, number of queries to the victim models. We can observe that the simple greedy attack can outperform the Pyro state-of-the-art method, and using genetic algorithm can further boost the results again. And on all the victim models, our methods also modify fewer variables and query the model for less times. We also find that if we use the generate adversarial example to train the model again, and it can enhance or improve the robustness of the victim models. So in the future, we plan to extend the attack to other models of the code and more transformations. We also plan to develop robust pre-trained models rather than gain robustness by 6.
Fantastic. You that was beautifully done. You were to get in stay in those 5 minutes. I think I ate up the first minute anyways. So fantastic. Thank you so much, so very much for the presentation. We will be taking questions and discussing the papers in more detail at the end of the session. So if you have questions, please feel free to put those in the chat. And I'll make sure that those get answered at the end. In the meantime, let's get to our next paper. To what extent do DNN-based image classification models make unreliable inferences? And this is being presented by Yongchan Tian. Thank you so much.
Okay, can you see my screen?
Yes, we see presenter mode. We don't see your slide. So I think you might want to swap your displays. Yeah, there we go. Yep, perfect.
I got all now here my voice from the speaker. Do you have section 2?
We don't see your slides anymore.
No, I only hear my voice from the speaker. I don't know whether you can hear me clearly.
Yes, but see, we're actually having a hard time hearing you. Am I the only one?
Okay.
There we go.
Anyway, let me start. Let me try.
Me too.
Okay, it's not just me.
Yeah, thank you. My name is Yongqiang. I'm a PhD student from Waterloo and Hong Kong University. I'm going to present our work towards trying to do DNN-based image classification models.
Yongqiang, we're actually having a really hard time hearing you. I'm not sure if the microphone is maybe a little muffled or something, but it's sounding really muffled. We're having a hard time hearing you.
Let me rejoin to test it again.
Okay, and we'll just go on to the next one and come back to you to make sure your audio reconnected. All right, thank you. So yeah, let's go to the next paper so we don't waste any time here. We're going to go ahead to demystifying the dependency challenge in kernel fuzzing, being presented by Yu Hao. So please share your work with
let me oh, wait a moment. Could you see my slides? Hello?
Sorry, I thought you could see my thumbs up. Yep, looks good.
So, okay. And could you hear me now?
Fantastic.
Okay, sure. I'm Yu Hao from University of California, Riverside. Today I will present our paper demystifying the dependency challenge in kernel fuzzing. Okay, so first I will introduce some background and the motivation of this paper. The Linux kernel is widely used in servers and cell phones, and the fuzzing has become one of the most popular and essential methods for uncovering the bugs and vulnerabilities. And the syscaller, which is the state of art, the art kernel fuzzer, has found or fixed more than 4,700 bugs in the Linux kernel. And then I will introduce how syscaller works. First, syscaller generates templates from the Linux kernel by human. The template, which is knowledge about the syscalls, includes the name of syscall, the argument of syscall, and the dependency between them. The syscaller could generate valid test cases from those templates and execute them in the Linux kernel. Then syscaller could pick interesting test cases by new coverage. From those interesting test cases, syscaller could then mutate them to generate more test cases. That's the high-level workflow of this color. But yeah, and in fact, we have efficient finding algorithm in this color, and we have sufficient long finding time. And there are also comprehensive templates for some kernel modules. But however, all of them can only achieve a coverage of 48%. So we want to know what else prevents this color to get more coverage. The answer is dependency challenge. And this paper want to figure out the root causes behind the dependency challenge in the kernel filing. Look at this example. The condition at line 1 has one uncovered branch, so it's belong to unresolved dependency. Since it's read the value from some global memory, which is field CDDA underscore method in CDI here. So it also belongs to unresolved dependency. And the code at line 6, write value to the field CDDA underscore method in CDI. So it is a white statement for the unresolved dependency at line 1. Because it can change the global memory to an effective value, it is also effective white statement for the unresolved dependency at line 1. And we define the dependency is the relationship between the unresolved dependency and its effective white statement. Notice that they can in different syscalls or even not in syscalls at all. So then I will directly introduce the final results of our root causes. In fact, we pick 4 different type of kernel module and run a long finding time on them. And we sample more than 100 unresolved dependency, and after more than and we write a lot of code for it, and after more than 300 human hours, finally we find 5 root causes. The biggest root cause is somehow surprising is dead code. They are related to some global memory, and they need inter-procedure analysis to decide they are dead code. So that's maybe the reason that they cannot be recognized by current solutions. So there's no way to cover those code for the kernel filing. The second one is environment dependency. The environment for the Linux kernel is mainly the input from hardware. So it needs some specific input from hardware to resolve those dependencies. Oh, sorry. And then the next one is the incomplete template. Although we have picked the kernel module with comprehensive template, we still find that there are some unresolved dependencies because of bugs in the template. So we need some technique to automate the generated template instead of human. And in fact, I'm working on this now. And another interesting reason is the unobserved dependency. In fact, besides the syscalls, there are some function can be triggered by some other interface of the Linux kernel. For example, the bottom half position, module init and exit function, callback function, interrupt, and so on. So the kernel finally needs to consider all of those different interfaces together in order to have a better coverage. And we conduct an in-depth investigation of dependence challenge in the kernel filing, and using a combination of static and manual analysis, we demonstrate challenge one analyzing the unresolved dependency in Linux kernel, and we distill the root cause of those unresolved dependencies. Thanks.
Fantastic. Thank you so much. All right, so we can keep the ball rolling. Let's go back actually to see if our last presentation will be able to hear a little better. You want to test the audio real quick?
Can you hear me?
Yes, perfect. Awesome. All right. So, yeah. Go ahead and share.
I don't know why. Yeah, I don't know why when share the slides, I always hear my voice very clearly in the speaker. I guess that's a problem. But I don't know how to address it.
Let's try again and see if maybe we can get it a little better this time. Or at least audible.
Can I see my slides?
Can see your slides. Can you talk a little more for us?
Hi, is the voice clear?
it's still a little shaky. I don't know. Is anyone else hearing the same thing as well? Just to make sure it's not just could be my machine. Okay, yeah. So it sounds like it might be. Is there a chance you have a different mic you can use, or like that might be the issue you think? Or I know my earphones don't always work as I would like for them to on certain platforms.
Can you hear me now?
Let's try. I can hear you. Yep. Let's try. Yeah, doing some movement. It sounds
share
better.
slides. It's a problem.
Let's try sharing your slides and see what it does now, because it sounds better to me already.
Okay. Hi. How about this time?
It's better. Keep talking.
Okay. I'm Yun Qiang, a PhD student at University of Waterloo and Hong Kong University. I'm going to present our work towards extended
It's still breaking in and out pretty bad. I think it's actually really challenging to hear. Let's keep debugging in the background. Let's get the next paper up, and we'll keep debugging that in the background. Hopefully, we can either try. I was about to say try a different mic, or if you have another co-author who's available to kind of maybe step in and help with the audio piece of this. But let's get the next person up so that we don't run out of time in our session for questions at the end. Let's get our demystifying the challenges and benefits of analyzing user-reported logs and bug reports. And this is being presented by Anran Chen. And so beautiful, perfect. So we'll take it away.
I will be presenting on paper, Demystifying the Challenges and Benefits of Analyzing User-Reported Log and Bug Reports, joint work with Dr. Peter Chen and Xiaowei Wang. There are many research work in the study of software logs, for example, studying logging practices or leveraging log in debugging. However, one problem is that the availability of log is limited due to privacy and technical concerns. Fortunately for researchers, we also find user-reported log in bug reports. They are logs that user attaches in bug reports to help developers better investigate the problem. However, there are still challenges in leveraging those logs, as those logs can be incomplete or irrelevant. Which lead to questions like this: how often do we find logs in bug reports? What characteristics do they have? Do they help to solve bugs? Can they provide information on the location of bugs? Those are the questions that we try to answer in this paper, and will show that the user-reported log, despite being incomplete, contain valuable information. We conducted a case study on 10 open-source Java systems. We collected over 8,800 bug reports and identifying two types of logs, log snippets and stack traces. From this data, we first investigate whether there's a difference in bug resolution time. We find that the bug report with log takes more time to resolve. There are two possibilities that influence the resolution time. First, the initial attached log might not be enough for debugging, so developers might ask for more log in the common section of bug reports, which delay the overall bug fixing process. Second, the bug fixes of those with logs are complex, so they take more time to resolve. Then we study the usefulness of those logs by comparing the overlaps between the log classes, so the classes that we find directly inside the logs, and the fixed classes, the classes that were modified to fix the bugs. We found that the majority of the bug report with logs contain direct overlaps with the bug fixing locations. We also find that the user-reported log provide a good indication of where the bug might be located. On average, the log classes can locate 44% of the fixed classes. Those findings lead to our third research question: why do some fixed classes have no overlaps with the log classes? We uncovered two reasons, and based on this, there are some implications that we'd like to share. First, the log classes may show the point of the failure, but not the root cause. In this example, we can see that the fault does not appear directly on the log, but rather on the execution path between two log lines. Motivated by this example, we further uncover the execution path between log lines. We find that based on the no overlapping bug reports, 28% of them have the fixed classes reachable by execution path. Therefore, we suggest that future study to we suggest that future study to consider using execution path reconstructed from log to provide additional debugging support. Another reason why there is no overlap is because of code evolution. We find that sometimes the source code that generates the log no longer exists. In such cases, developers might have additional challenges in understanding and fixing the bug. We encourage future study to utilize prior version of the source code to help developers analyzing bug reports. And that concludes our talk. We invite you to read our paper. There are a lot more information on it. We made our data available online. We also published an extension to this paper on bug localization. We hope you enjoyed this talk, and thank you very much for your time.
Fantastic. Great job. Fantastic work. So many exciting contributions being spoken about in the session. I'm loving it. So let's keep the ball rolling. I think we got one of our speakers trying to debug some audio issues. So sorry about that, guys. Got booted. So yeah, let's get on to the next presentation. Let's go to surveying developer experience with flaky tests. And this is Owen Perry.
Hey, my name's Owen. I'm a PhD student at the University of Sheffield in the UK, and I'll be presenting our recent work on understanding how software developers experience flaky test cases. So a flaky test is a test case that can pass and fail without any changes to the code under test. So they're a big problem in software development because they can disrupt continuous integration, they can limit the productivity of developers, and they can cause a loss of confidence in a test suite. The pain of flaky tests is felt across the whole spectrum of software development. So that's from small open source projects to the likes of very large companies like Google and Microsoft. So in this study, we looked at multiple sources to understand how developers define a flaky test, what they consider to be the impacts and causes of flakiness, and how they react to flaky tests. We designed a survey that we circulated on Twitter and LinkedIn as broadly as possible to collect responses from developers of as many different organizations as we could. In total, we received 170 responses. We also examined 38 threads on Stack Overflow for a perspective on the causes of flaky tests and the actions that developers take against them that was free of any self-reporting bias. So to achieve our aims, we reviewed published papers and grey literature like blog posts that were relevant to flaky tests to steer the design of a developer survey. The survey contained 11 questions that were a mixture of open-ended, allowing respondents to freely write text, and closed-ended, restricting respondents to a set number of choices. We collected our data set of Stack Overflow threads by searching with the keyword flaky test, and we only considered threads where the question asks about one or more specific flaky tests, as opposed to asking about handling flaky tests in general, and has an accepted answer. We applied simple numerical analysis to the responses to the close-ended survey questions and thematic analysis to the open-ended survey questions in the Stack Overflow threads. Specifically, we performed inductive thematic analysis, which involved collaboratively assigning one or more labels or codes to each response that captures their key concepts, and then from these codes, deriving higher-level themes. We designed 3 of our survey questions to capture some demographic information about our respondents. The first of these asked developers to indicate how often they encountered flaky tests, and only a very small minority of 3% said they never experienced them. Just under 56% stated that they experienced them on at least a monthly basis, so this suggests that flaky tests are a common phenomenon, emphasizing the importance of flaky test research. Our second demographics question asked respondents how many years of software development experience they had. As the results show, our participants were generally very experienced, with almost half having had 13 years or more. Finally, we asked which programming languages our respondents were currently using. They were allowed to select multiple languages from a large list, and this figure shows the top 10 most popular. This distribution roughly follows the most popular languages according to the 2021 Stack Overflow Developer Survey, giving us some reassurance that our participant population is broadly representative of the wider development community. Based on our findings and the findings of previous work, we concluded our study with 6 recommendations to both developers and researchers. The first is to consider beyond code when thinking about flaky tests and to pay attention to the execution environment and other third-party factors. Specifically, developers should be wary of how the behavior of test cases may differ in different environments, particularly when going from a local development environment to a CI environment. The second is to consider that flaky tests are not purely an annoying bug, but that they may indicate that the code under test is unreliable. Thirdly, the responses to several of our survey questions indicated that flaky tests are a particular problem to the effective deployment of CI. Therefore, researchers should consider possible approaches and techniques to mitigate this. Our fourth recommendation is for the developers to exercise particular care when writing the setup and teardown methods of their tests, since our findings indicated these to be a common cause of flakiness. We also found that many flaky tests may ultimately go undiagnosed by developers, and so our fifth recommendation is for researchers to consider automated approaches for this task. Finally, we recommend that developers repair flaky tests as soon as possible after identifying them to avoid them being ignored. That's it. Thanks very much for listening.
Nice. I love it. I didn't even have to feel like I was being rude to show my face in the middle of your presentation. Nice job. All right, so let's go back one more time and see if we can get this audio issue resolved so we can hear about DNN-based image classification. So do you want to try and share screen? Let's see what happens. Perfectly.
Okay. How about slides? Can I see slides?
So good. Everything looks good. Sounds good.
Okay. Okay. You want to
Perfect. We're in there. Let's go.
Okay. Thank you. Hi, everyone. My name is Yun Qiang. I'm a PhD student from Hong Kong University of Science and Technology, and also University of Waterloo. Our work is published in Empirical Software Engineering in 2021. This is a joint work by several universities. We know that DNN network is widely used for image classifications. It has good performance in terms of accuracy. However, it is challenging to understand how the inference is made by DNNs because the logic is encoded in weight and architecture. This is hard for human to interpret and comprehend. So this come up with the question, can we trust the inference made by DNN models? Here is an example, given this image, DNN models may tell us this is a play. However, we don't know whether this classification is based on the feature of the play. Actually, it's possible this classification is made by the feature of sky. So can we trust the inference in such cases? The answer is no. Otherwise, any image with sky will be classified as a play. So in other words, it's possible that the correct decision made by DNNs actually is based on the unreliable inference process. So in this study, we divide the feature image into 2 parts. First is the object relevant features, such as the feature encoded from the object. Here is the play. And also the object irrelevant features, which is encoded from background. So we argue that the inference made by DNN models should be majorly based on the object relevant features, which is a play, instead of the object irrelevant features. Otherwise, this inference cannot be trusted, and this model cannot be trusted because it classifies image based on specific background instead of the object. We name this property as object relevancy properties. So the first the objective of this study is propose a testing methodology to validate whether object relevancy property is violated by the DNN models. So we propose 2 metamorphic relations. The first one is that an image mutated by corrupting the feature of the target object should lead to the different inference results. Also, we have the second metamorphic relations, that is an image mutated by preserving the feature of the target object and corrupting other features should lead to a similar inference results. So based on these metamorphic relations, we construct new test cases, feed them to the DNN models, and then we check their results. At last, we check whether the metamorphic relations is violated or not. If yes, we label this inference as unreliable inferences. So we evaluate the effectiveness of our approach by manual check based on 4 models and 2 data sets. We found that the true positive rate is around 80%, and the false positive is majorly due to the dataset annotations. We also conducted an improved study to understand whether such unreliable inference is common. And here is some findings. The first one is that we found that such unreliable inference is common in DL models, especially for the pre-trained models collected from Kairos dataset. We also find that images with small objects are more likely to be unreliable. So we suggest the developers to pay more attention for such inferences. So the third one is that we found that such unreliable inferences will induce bias to the model evaluations. After removing such unreliable inferences, we found that top one accuracy of models actually is increased. So we recommend that the developers should consider such bias when, during the model evaluation phases. At last, we found that currently the normal training strategies cannot easily eliminate all unreliable inferences. We hope that more advanced training strategies will be proposed to address these issues. So basically, here is the summary of our papers. So more details in the papers, and feel free to contact me if you have any questions. Thank you.
Fantastic. Thank you so much. Glad we were able to finally get that worked out. And now let's go on to our final presentations. We have time for some questions I see starting to come in, which is going to be fuzzing class specifications. And that is going to be presented by, oh, I think I think you have to stop sharing your screen.
Yes, because I can't.
Chiang. Yep.
Okay,
oh,
there we go.
Perfect. All right. So Facundo Molina will be talking about fuzzing class specifications today. Take it.
Okay, thank you. Hi, everyone. This is Facundo Molina from University of Rio Cuarto in Argentina. And in this talk, I'm going to present fuzzing class specifications, a work developed in collaboration with Marcelo Damorim and Nazareno Aguirre. So to start, let me describe a typical automated analysis scenario. Usually, when we want to analyze our programs, we use some program analysis tool that provides us with some feedback on the behavior of our programs. And when we incorporate a specification of the expected behavior of the software, the analysis performed by these tools can be considerably improved, allowing us to catch more bugs or to have better guarantees on the behavior of the program. But unfortunately, specifications are seldom available. And this situation illustrates the relevance of the Oracle problem, which is the challenge of distinguishing between correct and incorrect software behavior. There are many approaches that one may take to the Oracle problem. One is to manually specify the expected behavior using some formalism. Another is to try to analyze the software in order to reveal general software faults, such as unexpected exceptions. And another approach is to try to derive a specification from existing software elements, such as a previous version of the system. Our work focuses in this last approach to the Oracle problem, and in a particular type of specification inference. We take a program under analysis and executions of this program, and then using a specification inference tool, we are able to report specifications or assertions on program points. And more precisely, our goal here is to infer specification capturing the current program behavior. Several specification inference techniques have been provided, in particular, the well-known tool DICON that uses dynamic analysis and an ad hoc template-based approach in order to infer assertions that belongs to a standard assertion language. But DICON has some known limitations. It typically reports false positives and redundant assertions, and also the assertions that it reports are simple arithmetic and logical expressions. In order to overcome these limitations, other techniques have been proposed, in particular, GAssert and EvoSpecs. These approaches uses evolutionary computation in order to explore a larger search space. They also use mutation-based techniques in order to report less and stronger assertions. And also they increase the expressiveness by incorporating further operators in their assertion languages. But there is a limitation that all of these techniques share, and that is that the assertion languages that they have are difficult to adapt to support further assertions. In this work, we propose a new technique for specification inference called SpecFuzzer. SpecFuzzer is built on top of Dicon. Dicon originally takes a program under analysis and a test suite exercise in this program, and then from a set of candidate assertions, it reports a set of likely invariants that are essentially assertions that are not falsified by the test suite. With the goal of removing the need of manually specifying new assertion, we incorporate an assertion grammar, and then by using a grammar-based fuzzer, we are able to produce thousands of candidate assertions that we provide to Dicon. Then when we execute Dicon, we are able to report many more likely invariants. And finally, with the goal of reporting only the assertions that are more relevant, we incorporate a mutation-based selector that discards the irrelevant or redundant assertions and report the most relevant ones. To evaluate our technique, we took 43 subjects from previous works, and then for each one of these subjects, we wrote the expected specifications. And then we first evaluated the effectiveness of grammar-based fuzzing at producing relevant assertions. And in this case, we were able to report more than 20,000 assertions while discovering 61% of the assertions in the ground truth. Then we incorporated the assertion selector and evaluated the performance of our selector. And in this case, we were able to reduce the reported assertion by 95% and still discover 52% of the assertions in the ground truth. And finally, we compare SpecFuzzer with alternative techniques. And in this experiment, we were able to report most of the assertions reported by the other tools and assertions that were part of the ground truth. And also, we were able to outperform the other tools in terms of discovered assertions. And finally, to conclude, I would like to highlight some remarks. First, the Oracle problem is a relevant problem in software engineering. Our technique uses grammar-based fuzzing and mutation-based selection to effectively improve dynamic invariant detection. And specification inference can still be improved in terms of scalability, expressiveness, and precision. So thank you very much for listening.
Fantastic. Thank you so much. So many great presentations. I'm going to ask that the authors, you don't have to necessarily turn your camera on, although it would be lovely to see faces, but I would like to have all of the authors up on the main stage here, so to speak, which I think is done by either unmuting yourself or turning your camera off, whichever you prefer, so that we can get through some Q&A in the last few minutes that we have here. Starting with a couple of questions that came into the chat. And of course, I do encourage viewers to add any questions to the chat that they have, and I'll make sure and get to those as well, time permitting. So the first couple of questions I have here for Owen and his work, or your team's work. So the first question was, did you also study what were the common root causes of flakiness that developers face, or which ones do they find hard to debug?
So in the actual questionnaire that we circulated, one of the questions was, we gave a list of causes that we identified from looking at the literature. We basically said, in the projects you're currently working on, how often do you identify flaky tests of this cause? So the most popular one was issues in setup and teardown between test runs. Second most common was network-based issues, and the third most common one was unknown, so where they just didn't really have a clue where the flakiness came from. We didn't specifically ask which ones they found difficult to debug, although parts of the questionnaire, like I said in the talk, were open-ended, and a couple of people said that handling date and time logic can be particularly tricky and can cause flakiness when there's time zone issues or when one system has a different level of time precision than another. So that was something that came out of our open-ended questions.
Fantastic, and thank you for the question. Another question for you while we got you going here. So, what kind of systems did you investigate, and did it involve some machine learning based components, which of course may lead to more flakiness, as you just alluded to?
So we didn't directly investigate any systems. We just asked developers what their thoughts were. But about the other part of your question, specifically to do with machine learning programs, one of the difficulties of testing machine learning algorithms is that they're often non-deterministic by design to an extent. And this makes writing a deterministic assertion such that this should always be true very difficult to do. So really that's kind of a limitation of how we test, I suppose. And there's always going to be a very small probability of flakiness when you're testing any system that has randomization in it. One way of getting around that is setting seeds and things like that, but that can kind of limit the power of the test if you limit the code under test.
Absolutely.
Yeah, thanks
Fantastic.
for your answer.
Yeah, I was about to say fantastic answer, and thank you for your question. So let's go on to the next question that I have in my order over here is for Yong Chang. So we have a question that says, how do you separate the relevant and irrelevant, for example, background features? Do you use some manually annotated boundary or some automated methods like semantic segmentation?
Yeah, so here's the story. So in the paper, what we use is the annotation from the data set, which is easily to achieve, and it's relatively it is correct. We tried some semantic segmentations, but the result is not good. And we found that if the annotation is not good, it will affect the effectiveness of our approach. So eventually in the paper, what we use is annotation boundary from the data set. But
Okay, I have
it is easily to transfer to the semantic segmentations, but it will induce false positives.
Yeah, I have a follow-up question. So when you have annotated data, so it can be just like a square, like circle, or an object, or it's a very detailed, like to describe the boundary. So which one is the case?
Okay, so in ImageNet, what they give is the bounding box. It's a square mentioned by you. But in the Microsoft Cocoa dataset, there is a very clear mask, like it has the entire boundary of the object, which is relatively accurate than the ImageNet. Although ImageNet is quite long ago.
Yeah, it's very interesting because I think it may lead to a difference. Why? Because for the machine learning, the system, maybe it's not, so it can decide, like, I mean, have an output based on the boundary, based on the shape, instead of like what the color it is, whatever. So if the shape you use to cover, to replace, to separate the object is different, maybe it leads to a different result. And it can be a search validity or can be an interesting thing to investigate. Yeah, that's my question, my set.
Yeah. So actually, if you so I remember, I can't remember whether it's on paper, but in our experiment we try to do some actual work for the boundary. So in order to cancel elevate such a fact from the shape of the boundary, but it had to achieve a perfect isolation of the background and the object.
Yeah.
Fantastic. Very nice discussion there. Thanks for the really thought-invoking questions. So another question, actually, while you're already talking about your work that just came into the chat, have you thought of using the mutated images that you generate for checking the metamorphic relations? For example, an image where the object relevant features are preserved, but the background changed, for further training the models?
Yeah, actually, this is I think it's ongoing, but I don't know whether we will make it publish, because if it's just normal adversary training, it seems the contribution to the academic community is not significant. But yeah, we are trying this, and I think we achieve some good results for some companies, some industry products for this product, for this retraining process.
Fantastic. Awesome. Thank you so much for the answer. And of course, thank you for the question. Still taking questions, but I do have another one that was asked for Facundo. So would this work on big functions, or what is the size of the functions in the evaluation for your paper?
Okay, thank you very much for this interesting question. And first, the size of the function that we evaluated on the paper are relatively small because they were functions for which we were able to produce the ground truth assertions, and they were, let's say, easy to comprehend. And regarding the first question, if this will work for big functions, I think yes, because our approach doesn't depend on the complexity of the methods, but more importantly in the states that they produce. But something that will happen if you try to analyze big functions is that our selection process that is based on the assertion selection process that is based on mutation will take much more time, because if you have a big piece of code, you will have many mutants, so that process will be expensive.
Fantastic. Thank you for that. And again, thanks for the great question. I'll keep a monitor on the chat, but while we're waiting and kind of to make sure we fill this time, I had a question that I think these virtual experience or virtual presentations can be a bit difficult to really get a sense of what the real contribution is that we're trying to propagate here. And I'm curious for each of the authors or the presenters here, if you had to pick a single kind of summative finding or implication of the work that you presented today that you want the audience to walk away with, what would that be?
Okay, I can start. Okay. So, I mean, this year, I think the most influential paper is on the naturalness of software engineering, right, of software. And it's actually this paper also, because the concept of naturalness is, in my paper, like the naturalness requirement for attacking also come from that paper. So because currently people, they are doing a lot of robustness evaluation of the model of the code, but they just replace whatever they have, very long variable names, which people don't like. So my take-home message will be, if you are doing something like robust evaluation for model code, you need to take care about human as your audience as well, which means you need to take care of the naturalness. So that's it.
Fantastic. I think a great and appropriate message for a lot of the directions I think that the ICSI community is going with respect to some of the contributions we make. So thank you so much for that. Who wants to go next?
Can I go next?
Yeah.
So I'd say from our study, there's probably two important lessons to take away that I'd like to emphasize. So the first one is that when thinking about flakiness, you need to consider beyond your own code, so i.e. the code of the test case and the code that the test case covers. So software obviously has so many dependencies on its execution environment. And among many things, that can also lead to unexpected flakiness. And that's something that developers should be very wary of, particularly when going from a local development environment where tests may be very stable to going to a CI environment, particularly if it's a cloud-based CI environment where certain things like input-output may have unexpected delays. So that's one thing. The second thing is I feel that flaky tests should not be considered to be completely useless either. So oftentimes if a test is flaky, it's not necessarily just because the test case is broken or there's a bug in it. It can also be because the code that it tests is actually flawed and there's some kind of unexpected non-determinism going on. So yeah, I'd say those are the two most important lessons to take away from the work we did.
Fantastic. Who wants to go next? We'll finish this round, and then I have another question that I'm going to try and make time for. So who wants to go next and tell us the big takeaway from their work that they presented today?
I can go next. Okay. So for our paper, it's pretty straightforward, right? We're just doing our research on user-reported logs. And the idea is that user-reported logs are limited, so they are very short. The information within them is just textual information, right? And for the past papers, people have been using just the textual information on the logs. And there are actually more information that's hidden between the log lines. And this idea of, I guess, this paper that we're
getting some
doing.
clicking noise or feedback as you're talking. I don't know if the mic is maybe rubbing against your jacket on your
Oh,
head.
I'm sorry.
No, it's okay. It's totally fine. Go ahead. Continue.
Yeah, so the idea is that if we try to recreate the execution path between the logs, and that's pretty easy and straightforward to do. We just use static analysis, right? We do the call graph for the source code, and we just try to trace the execution between two log lines, and we can uncover the whole execution between the log, and we would have access to more information for developers. And that's the major takeaway from this paper. And people can really encourage future research to consider this approach, try to recover the execution path between logs and to use this information to enhance whatever debugging information that we have for developers whenever we try to do, automatic for bug localization or other sort of logging practices study. And yeah, that summarizes our paper. Thank you.
Beautiful. Thank you so much. Fantastic. Who wants to go next?
Okay, I can go next. Can you hear me?
Yep.
Okay, perfect. Okay, I think that the main takeaway of our work is that first, in our context, test generation focuses more on generating inputs or tests that may reveal faults, but not too much in generating good and strong assertions. And also that the problem of generating meaningful assertions is like very difficult. And I think that well, our work and also the techniques that we compare with are some attempts to work in this direction, right? Of producing meaningful assertions for software, so we can improve the other program analysis activities. So I think that the main takeaway is that, right, the challenge, how challenging it is to create assertions, and that there is a lot of let's say room for improvement there in terms of expressiveness of the assertion that we're able to generate, in terms of scalability, be able to generate assertions for larger programs, and also in terms of precision. Sometimes it's very difficult to produce do not produce false positives. So that's it. Thanks.
Fantastic. A narrative that I and the work that my lab is doing can very much relate to. So I'm very excited to see what comes of the things that you're working on. And hopefully maybe down the line, there's room for collaboration, because really excited to hear that that's a direction that you're working on. All right.
Okay, great. Thanks.
I keep getting booted for some reason. I think it's my mouse decides to kick me out. Sorry about that. Who's up next for sharing their takeaway? I think we'll only have one or two left here.
Yeah, I can share my our work's takeaway. So, yeah, I think the takeaway, the most important is that for deep learning models or deep learning systems, even the results you correct, actually the underlying inference process could be wrong. In such cases, depends on the situation, depends on where you deploy your models. The problem could be serious, so be careful for such issues. Yeah.
Fantastic. Lovely, lovely takeaways. Who wants to go next?
Okay, so in fact, I maybe not the takeaway of my papers. It's something from the difference between the software conference and the security conference. It's my first time to attend a software conference. I found that for software, it's don't assume that the developer could produce many good code, or it don't assume that developer could account for their code. They try to use some automatic system, for example, CI or something, to keep most people could generate some usable code. But for security, it's focused on, okay, developer shouldn't push some bad code. It must be as good as possible. So for example, the kernel, every commit in the kernel must discuss a lot of, and finally it's at least look like must be perfect or something. So that's a very big different I learned from the this time when I joined a software conference. So in fact, my work just focus on try to make, even we have everything ready for the current kernel, we try to want to make it better, maybe even close to the perfect, but it's not possible in general software for most situation, for most companies. I think that's a very big difference. I learned from this this conference.
Yeah, no, I definitely, it's always interesting to hear comparisons to other communities, even especially other technical communities. But welcome to ICSE and the software engineering community. We are a welcoming, friendly community, and so we are excited to have you and to see where all of this goes as well. So let's get to our next takeaway. Who wants to go next? I think we have two more. One more. Anran, I don't think have you already done your takeaway?
Yep. Yeah.
Okay, so are we done? Oh wait, no.
No, I think we have gone through everyone.
Perfect. Look at that. All right, well, let's get back to this. Since we have a few minutes left, I did get another question in the chat that I want us to get back to, and I think this was for Owen, if I'm not mistaken. Yep. So regarding how developers fix flaky tests, I was wondering whether you observed cases in which the test assertions were relaxed or weakened to overcome flakiness.
So in this specific study, we took a slightly broader view of actions against flaky tests, of which fixing was one of them. So we didn't really dig around too much into the weeds of how they fixed them. But from previous work that our group has done and from previous studies, sort of widening the goalposts, if you like, so widening the ranges of acceptable values in assertions is a very common approach to fixing flaky tests. And this actually links a little bit to a previous question about ML. So this is very commonly seen in flaky tests in ML projects, where you could think of it as a bit of a trade-off between the reliability of the test, since when you relax the assertion, you're decreasing the chance of flaky test. So it's a trade-off between reliability, but also the power of the test, since as you widen the assertion, you're kind of weakening the oracle as well. So that's a trade-off that developers ought to think about.
Quick follow-up on that. Do you know if there's any work that exists that has already looked at those types of trade-offs in practice, or?
Well, there is, so not specifically thinking about that trade-off, but there is an automated technique for repairing these kinds of flaky tests that does actually adjust assertions automatically. I can put a link to the paper in the chat if anyone's interested.
Please, I'm very interested. Absolutely.
Yep, I'll dig that out now.
Awesome. Any other questions or thoughts that any of our authors want to share before we end this session? I think we have less than 60 seconds before it stops recording. Any gems we need to make sure get documented for the history books here, or are we thinking we're good?